We built hundreds of interactive models in the area of inequality. One of the models helps you to solve these types of SAT problems. So here, the x-axis represents the cost of walnuts, and the y-axis represents the cost of almonds. This problem statement is given in a graphical form. So the question is, given these constraints, how many walnuts and almonds can be purchased? So here, we have various options on how to solve these problems. Before looking into this, just interact with this model and see how quickly you can resolve this problem, which is commonly asked in the SAT. So, Nora wants to spend a maximum of $20 for purchasing fruit for a party. Each pound of apples costs $4, and each pound of oranges costs $3. The inequality 4a plus 3o is less than or equal to 20 represents the number of pounds of apples, A, and oranges, O, Nora can buy on her budget. If she buys 4 pounds of apples, how many pounds of oranges can she buy? So you can interact here. So if she buys 3 pounds of apples and buys 2 pounds of oranges, that is represented at point 3, 2, which is lying in this shaded region. So this model illustrates that as long as a point sits in this shaded region, this point will satisfy the inequality. For example, if Nora buys 5 pounds of apples, she can't buy 2 pounds of oranges because now the point is outside of the region. So to pull this value inside of the region, either you need to bring down the x-axis or you can bring down the y-axis. So now here, you can bring down the x-axis. However, this point is still outside of the region. So Nora cannot buy 5 pounds of apples and 1 pound of oranges. Now you can push it more, and you can push the x-axis. If Nora bought 2 pounds of apples and 1 pound of orange, that would be possible. So any point in this region will satisfy the inequality, and if anything is outside of it, then this inequality will not be satisfied. So now you can interact with this. You can change the cost of the apples and oranges and change the total budget. Now this point doesn't satisfy the inequality. So as long as the point is inside the region, then the point satisfies the inequality. Now go back to the test questions. We now have to see which point satisfies the inequality. 2 pounds of walnuts and 1 pound of almonds would be at point 2, 1. If we look for 2, 1, we can see that it does not lie in the region, so it does not satisfy the inequality. 3, 7 would lie also outside of the shaded region, so it too does not satisfy the inequality. 4, 2 does not satisfy the inequality. However, 2, 4 sits exactly here, so it satisfies the inequality. So we now know that 2 pounds of walnuts and 4 pounds of almonds is the answer. If you interact with this model, you can solve this problem in less than 30 seconds. So visit www.interactivesatmath to interact with this model.